In this problem, it's going to be a lot easier for you to simplify before you do the derivative. So we are going to simplify this inside here, and it's really just going to look like d dx of 2x, and then the derivative of that is just going to be 2. So you have answer choice E. A little bit of a side note for us to remember, the natural log of e to the x is just x. Natural log of e is 1. For the next one, we are going to have to do the derivative on both sides, and this is just telling us that we're going to stay in the first two quadrants. Now the derivative of sine of x is going to be cosine of x times the derivative of x, which is 1. And the derivative of e to the stuff is going to be stuff prime, so that's going to be 1 dy dx times e to the stuff. And now this wants us to rewrite this in terms of x. So for this one, we're going to have cosine of x over e to the y is equal to dy dx. Now this is where this one's kind of tricky. We can't leave e to the y because we need it in terms of x. So we know e to the y is sine of x. So we know cosine x over sine x is equal to dy dx, and we know that cosine over sine is cotangent. So we have answer choice C. This next problem, very straightforward problem. We're doing the derivative, and we have this written out as a polynomial. So we just do the individual derivative of each term. The derivative of x is 1 plus the derivative of sine of x is cosine x. Our correct answer choice should be A. This problem, we have our exponent on the trig function, so it's a great idea to go ahead and rewrite this, moving that exponent to the outside to help us remember that we would have chain rule here. Y prime, we do the derivative of the outside first, times the derivative of the inside, which is going to give us negative sine of 3x, and then finally the derivative of our angle. And so for sure we're going to have 2 times a negative times 3, so our coefficient has to be negative 6, and the answer choice is A is the only one that contains that. Now we're finding the value of dy dx at a given point, and when you see this point, that means let's not simplify. We are just going to substitute in after we do our derivative. So y prime is going to be equal to, and we do stuff prime, and this is written as a polynomial, so we can go through here and just do our derivative of each term, and that is all over our stuff. Now we're going to evaluate y prime at the point 1, 0. So we're going to have 2 plus, well, that 0 in place of y, every bit of that's going to go out to 0 over 1 squared plus 0 squared. So we have an answer of 2, which is answer choice D. For this one, g is a continuous function on a closed interval from 0 to 1. We know g at 0 is 1 and g at 1 is 0. Which of the following is not necessarily true? So we're looking for something that cannot be true. I would go ahead and plot the points that we know. We know 0, 1. So I know that point there. We're all the way up here at 1. We have the point 0, 1. And then we have the point 1, 0. Now it's tempting to connect those, but we don't know what the shape of that function is. All we know about is just this little information right inside here. That's all we know. So there exists an A number h in 0, 1 such that g at h is bigger than g at x. Well, again, this is saying not necessarily true. So this one could be true. Here, if g at a, then well, that could be true, but not necessarily, so don't know for sure on that one. we need something that we know would have to be false no matter what. And right here, notice how these two are very similar, and the only difference in these would be these y values. So what this is saying is one of these has a y value that could be 1/2, whereas another y value could be 1.5. And honestly, the correct answer here would be D. D is not necessarily true because this y value, keep in mind the highest y value that we have here is 1. This is saying we have a y value at 1.5. We don't know that for sure. All these other things are occurring inside our given interval. They could happen. This one, there's no way it can happen. So the right answer is D. Okay, for this problem, notice x is approaching infinity. So we are talking about the end behavior. And this was when we talked about a power struggle. We need to see where do we have more power at. So the highest power that I see on top is going to be 4n squared. In the denominator, the biggest power I see is n squared. So notice these two, the power is balanced, and so they are going to technically, well, we can think of it as canceling each other out, and so I'm left with the ratio of 4/1, so that tells me my answer is 4. For our next problem, we do have a limit, and please keep in mind the first thing that we need to do for a limit is to substitute in our limit value just to see. So in the numerator, I would have 4 plus 2 minus 6. In the denominator, I'm going to have 4 minus 4. So we have 0 over 0, which means we need to factor. We probably have a hole in the graph. So let's rewrite our limit as x approaches 2. And we're going to factor the top, so that's going to be x plus 3 times x minus 2. And in the denominator, we're going to have x minus 2 times x plus 2. Those x minus 2's will cancel, and now we resub in our limit. And so we're going to get 5 in the numerator and 4 in the denominator. So the correct answer for this one is D. So for our last problem, we are writing the equation of a tangent line, and we're going through these points. So the first thing I would do is to look over at our answer choices, but notice they have the y value correct and they have the x value correct. So there's no sense in me even starting to write out that equation. All I need to do is find the derivative value. So let's go ahead and find our derivative. We're going to have 2x minus 3 times, this is going to be product rule. So I have the first times the derivative of the second, which is going to be 1 dy dx, or 1 y prime, plus second times derivative of the first, and then all of that's going to equal 0. Now from here, I would just substitute in. So in place of x, I have 1, so 2 times 1, 2, minus 3 times y prime, plus negative 3. And all of that equals 0. So I would go ahead and use my distributive property here. We have 2 minus 3 y prime. And let's see, negative 3 times a negative 3 plus 9 equals 0. And now solve for y prime. So 9 and 2 is 11. So we're going to subtract that over. So very quickly, looking at our answer choices, we see that answer choice E is going to have to be the correct one.